What's up guys, this is What's Up Chan. Today in my video I'm gonna share what I learned, what I was when I was studying physics in my school. And here this is this book that I studied recently, and it contained really interesting fact that I have been really wanting to know. The contents is about heat, and especially heat. I don't know if you guys can see this, but I'm gonna explain. Actually, the contents were about heat, energy, the hotness, and there's about flow of heat. And become more specific, then I'm gonna go with the latent heat of vaporization and latent of heat of fusion. Now, let's move the screen, and I'm gonna explain about this more scientifically and tell you how I was really fascinated to know this.
Now let's move on to the page. The definition of latent heat of vaporization is this: the amount of heat needed to change 1 gram of a liquid substance at its normal boiling temperature into a gas at the same temperature. I'll give you an example about water. Think about water, which is in a liquid state. We all know by sense that water needs 100 degrees Celsius to boil the water so that it becomes gas. And in scientific measure, it exactly needs 100 calorie to raise up from 0 degree water to 100 degree Celsius water of 1 gram. Okay, so we need 100 calorie to change the degree 100 degrees Celsius of 1 gram of water. But it doesn't mean even if the water reaches 100 degrees Celsius, it doesn't become the state of gas immediately. The water that reaches 100 degrees Celsius needs to get a specific amount of heat, which is the latent heat of vaporization, to become the state of gas. It is because the state of power attracting each other of molecules between liquid and gas is different. It needs some amount of heat so that the water can break apart the power of attraction between molecules so that it becomes the state of gas. And the specific amount of heat needed for vaporization of water of 1 gram is 540 calories per gram. What about latent heat of fusion? It is same thing, but it is the energy needed for a solid, like ice, to become the state of liquid. Like what I said in the vaporization section, it does not become naturally a water just because ice reaches the temperature of 0 degrees Celsius. Even though the solid state of water, which is ice, reaches 0 degree Celsius, it needs to obtain specific amount of heat so that its molecular state structure changes into liquid, and the amount of heat needed is 80 calories per gram. And in other sense, it also works the same. Just as the heat of vaporization needs 540 calories gram absorbed, when the gas becomes liquid back, it may express 540 calories exactly, like it presses out, and which is also for solidification. Now, why did I say it is so interesting? It is because I was able to understand how our widely used machine, refrigerator, and air conditioner works. yeah, I was able to understand how it works, and I could also figure out, even if we touch the machine, we know it is hot. And but I was always wondering how it makes us cool while the machine is really hot. And now I found the answer while I was studying this latent heat, and I'm gonna explain you guys how it works, how these machines follow the mechanism of heat. You know what? The basic mechanism is same with this. Yeah, it says hand sanitizer, but let's say this is an alcohol. When you guys put alcohol onto your hands, we all feel our hands are cold. Do you know why? I will explain. When we put sanitizer in our hands and mix it, I'm not mix, but put on it, the alcohol evaporates, or the alcohol vaporizes, which means this alcohol changed state from liquid to gas. But just like what I said, to change state from liquid to gas, it needs furthermore great amount of heat so that its state can be converted, the latent heat. Then from what does the alcohol get latent heat to change its states? It's our body temperature. As we put alcohol into our hands, the alcohol meets with the comparatively hot heat from our hand, and it absorbs the heat and it becomes gas. But there's a law of conservation of energy by Isaac Newton, and heat is form of energy. Heat cannot be created nor destroyed. Following this formula, just as alcohol absorbs heat, our body temperature, our body, especially hand, lose heat because our heat is taken away to help alcohol to vaporize or to evaporize. And that is why we feel our hands are cold, because we lost heat by sanitizer, by alcohol. In simple words, heat from our body moved from our body to the alcohol, and alcohol changes states thanks to the heat it took away from us. And this simple mechanism works same in refrigerator and air conditioner. I'm gonna explain only about the mechanism of refrigerator because it's the same. There's same things to explain both refrigerator and air conditioner. This is the structure or how it looks inside refrigerator. This is coolness, and there's a food to make it cool down. And inside refrigerator, surrounding the cooling box, this is the cooling box, it always contains some liquid, or let's say it is water, and the water is surrounding this cooling box. So what happens we put some foods inside the refrigerator? It will emit heat, right? Because every substance have heat, and they all want to emit their heat so that it will be cooled down, especially in this cool area. So it emits heat, and as the heat emits, it begins to warm the surface, and as it warms the space, the water surrounding it gets hit, and of course, since the heat there is not enough, there will be a source of engine that provides more heat to this water. Then as if this water is heated, it may reach the latent heat of vaporization, and it becomes gas. And just again I repeat, to become gas from liquid, it needs to absorb lots of heat. And this heat is absorbed from inside box. And just like our hands are cooled down because of alcohol, just because water is vaporized, the heat inside is taken away. And what happens to the place where heat is taken away? It must be cool or cold. So it is really simple, and and that is why the foods are able to be kept cool, and the area inside the box is always cool. All thanks to the principle of evaporization that absorbs heat. And you know what? For the next step, as the gas are emitted, it follows through a specific pipe connected to the outside, and as the gas newly produced gas evaporates and goes out of refrigerator, it suddenly condenses down, which means it becomes the liquid state of water, because the state of gas was only temporary. And just as the water is emitted again, the heat, like 540 calorie per 1 gram of water, are emitted also. So it means the heat provided by the food are taken away to the outside with the emission of liquid state of water. And that is why the place near refrigerator is always hot, and the machine itself is kept hot, because it not only because it generates electricity, but also because it absorbs heat from inside foods. And this same mechanism works in an air conditioner. It emits cool down because cool down that is made as water is evaporized, and that is why always air conditioner emits water out of it as it cools the space. So this was what I learned today, and this was What's Up Chan. Thank you for listening, and I hope you guys also were fascinated to know this interesting fact. Please give me a like.